Good morning and good afternoon to everybody out there. Can you see it? Yes? Good. So I'm John Kreisa from Hortonworks, and thank everybody for joining today. What I'm going to talk about is two topics. First, I want to talk about the drivers for the modern data architecture that is evolving. And then I want to talk about Apache Hadoop's role specifically in that modern data architecture. And then I'll pass it over to Steve to talk around the data warehouse role in the modern data architecture. So let me go ahead and get started. First, let's look at a pretty simplified diagram, admittedly, but a diagram no less that is representative of the architecture that most organizations have today in some form or fashion. It's collecting traditional transactional information, flowing it through to relational systems, enterprise data warehouse systems, and discovery platforms to analyze and store that data, and then pass that information on to or be used by packaged analytic applications, business intelligence tools, various kinds of analytics to gain insight into businesses. Almost every organization today has this kind of existing data architecture in some form or fashion. And granted, it is a simplified view, but really it kind of represents how the data flows through the organization. But if we look at some of the trends and drivers of what's changing and what's driving the modern data architecture, a lot of that comes from data and the explosion of data types that are really coming onto organizations now. If you look at some recent analysis by industry analyst group IDC, you see that their projections of growth of data for organizations is really quite astounding. So, for example, 50x data growth between 2010 and 2020. So we're well, starting down that path already, and your organization may be experiencing some of this. That's 2.8 zettabytes of data created and replicated in 2012. So tremendous amounts of data that is growing. One of the key standouts there is machine-generated data, and that's growing by 15x. That's our cell phones and every kind of device that has a sensor attached to it that's collecting that data, and data that really represents an opportunity for organizations to find and create new analytic applications and new business opportunities. Now, what's also interesting in the IDC data is that 85% of that data comes from new data types, data that wasn't traditionally being captured by systems that organizations have. So this is net new kinds of information that can give new insight if it can be cost-effectively captured and analyzed and blended with those existing systems. So that's some data from IDC. If we look at something, data and information from the McKinsey Global Institute, the U.S. has about a third of the world's data. So big data for the U.S. represents a tremendous opportunity for this organization. In fact, it represents a tremendous opportunity for all enterprises globally to capture that information, provide analytics on that information, again, to provide net new applications. And then if we look at some data from Gartner, Gartner also echoes really that same kind of study and use of data, and in fact with a focus on Hadoop. 65% of analytic applications will be using Hadoop from the inside on 2015 as a kind of core storage and analytic platform. Now there's also a general increase in the number of Hadoop-enabled relational database systems and database management systems, and Gartner research points to a very, very clear advantage, 20% advantage for organizations that are leveraging modern information management systems to outperform their peers by 2015. So organizations that can get a handle on these new data types using technologies like Apache Hadoop stand to have a substantial advantage in the marketplace over their competitors. So it's clearly an imperative for organizations to do, but what are they going to do? They have a tremendous amount of data. We see here from IDC in the number. So this traditional architecture is really put under a lot of pressure. A lot of pressure from this growth in data, the kinds of data like machine data. And the issue is that it's 85% of this data is new data types. It's data types that weren't really designed or really thought of in this traditional architecture. So it's putting a tremendous amount of pressure on that architecture because of the scale of the data, the velocity of the data, the variety of the data, all of the kind of classic 3Bs, if you will, of the data are putting pressure on that existing infrastructure. So, of course, it's necessary to think about new components, new pieces to that infrastructure as we start to talk about what a modern data architecture looks like. And in fact, modern data architecture is going to be one that includes Apache Hadoop. Apache Hadoop is a component that sits alongside and enhances those existing components that they're using, something that will allow you to cost effectively capture the new data sources that you're using and then exchange and process and transform those data types for long-term storage into and exchange them with your discovery platform, your data warehouse, and your other components, as well as up to the application layer, the business analytics and the applications that are used within the enterprise. So Hadoop is something that will sit inside of that modern data architecture. The modern data architecture will include Hadoop, but it will also include those critical components of the relational database system, the enterprise data warehouse, and the discovery platform, things that are already being used in the enterprise today, still have all of their value. Now you have Hadoop, which can both offload low-value workloads and provide long-term storage for those new data sources and long-term storage for some of the classic data sources as well. So this is the modern data architecture that we see. We see this at Hortonworks within our customer base, within the organizations who are looking to deploy Hadoop. Those both leading organizations and then more traditional organizations now are starting to come to this and realize this as the architecture that they'll have going forward. Hadoop will play a key component of their architecture as they continue to move forward within their deployments. So let me talk a little bit about Apache Hadoop's role within the modern data architecture. So I want to start off with just a little bit more detail on the data types because that's really what is being stored in Hadoop. So from our perspective, we see 6 data types, types of data that are being stored in Hadoop. So first is social data. That is information that is collected from the web, from rating sites and comment sites and various ways that your customers and your clients can comment on services and products. This is very common on websites, very common through even social channels like blogs and Twitter and all those different places that you would need to and want to collect the kind of social sentiment about your products and your brand, and all that information typically comes in a fairly large volume, comes in an unstructured way. That's a very common type of data that is collected within Hadoop. Secondly, clickstream data. So many of the interactions that companies have with their customers and potential prospects is through the website. So by having the ability to capture that interaction that you have with your customers through clickstream data and analyze the visitors and the trails, you can figure out who was visiting, what were the paths that they took, what kinds of things were they interested in. It gives you the ability to understand pre-transaction behavior that a user might have before they buy or purchase a product, or perhaps when they don't. What things did they look at? What web pages did they see? What ads did they get shown? All of that experience that they have, and you can figure out what the patterns are that lead up to successful purchases or also lead up to unsuccessful purchases and allow you to customize and optimize. Sensor and machine data, also very common. In fact, one of the ones that we look back at the IDC study as one of the fastest growing types of data that is being collected, and that is perfect for Apache Hadoop. Sensor and machine data comes off of almost every device these days. Every kind of digital device and analog device is collecting some information about itself, whether it's a jet engine, whether it's a washing machine. I was in the Home Depot the other day, and the refrigerators were collecting data and sending that data back. So any kind of device is collecting data. That offers an opportunity for providing better services, providing better support, and all of that data comes at a very, very high volume. Geospatial data, data about where a product or a service is being delivered, about where a user or a customer is, about where a breakdown occurs, all of that kind of geospatial data is also being collected at a very high volume. It's very, very useful in terms of being able to deliver targeted services to users. Server logs, so log files come off of applications, log files come off of search tools, log files come off of really almost every kind of application and device. And those log files will help you and help your organization get insight into potential for errors, patterns, lots of different details that you can get off of server log data. And then finally, unstructured text, kind of your standard, I'll call it catch-all bucket of data types, really around text and video and pictures that will give you traditional insight. So any one of these data types can give tremendous insight. What we see commonly at Hortonworks is these types of data being combined at massive scale to provide new kinds of analysis, to build new kinds of applications, and to provide new kinds of insight. Now, they're very commonly combined with those traditional data sources, and this data, once processed and cleaned, can be easily exchanged with my data warehouse and my discovery platform for further analysis or more iterative analysis. But traditionally, the natural landing place for these kinds of data is in Hadoop. So one of the common ways that we see Hadoop being used is in the modern data architecture, and one of the terms, I'll say, that is becoming more and more common is around a shared data lake. And what that means is that organizations are looking for a place to really take all of the data that they are collecting, all the data that's streaming in, if you will, to use the analogy, into their organization and land it somewhere in a low-cost, highly scalable way. And that's what they're using Apache Hadoop for, because that's what Hadoop was designed to do. So they're taking and storing all of that data into this common shared data lake. Now, what they'll do is, and this is something that most organizations do as they tend to mature, they'll sort of start looking for a way to use Hadoop. They'll pick a small singular application, but once they tend to mature, they tend to look at the data lake as kind of their end game architecture for how Hadoop will sit and play alongside of their existing infrastructure. That's going to give them broad value because they're going to collect all of that data and they can analyze it from custom applications, new packaged applications, their existing analytic tools, and of course they can exchange that data easily back and forth with their existing data systems due to tight integration. Some of the integration which you'll hear from Steve, for example, when he talks about data warehouse and the kinds of things that Teradata can do with Hadoop. So this is the modern data architecture applied in the form of a shared data lake. It gives organizations that ability to collect and land data, and then once they do that kind of simple processing, transformation workloads, or in some cases simple analytics, then they can take that data and exchange it with the other systems that they have. Now it's key here also that that Hadoop sits within their architecture and it allows them to take advantage of the skills that they have. In fact, very importantly, they want to be able to take advantage of those skills within their overall data architecture. Now, the drivers here are both that modern data architecture, which we're spending some time on today, and as well business applications, a topic that we'll cover in a future webinar. But the modern data architecture has Hadoop as that central role, and it's really about driving efficiency within the organization. So this is one of the things that you can do typical common tasks and workloads more efficient and more cost effectively when you move those to Hadoop. So it allows you to do kind of take some of those traditional server log and clickstream data, for example, those data sets, and use those and process them in Hadoop. And you can do that, again, more efficiently than you could before. So what are some of the requirements for adopting Hadoop as part of your modern data architecture? I want to make sure that I cover those, that you have a sense of the things that you should be looking for and thinking about in terms of Hadoop and the modern data architecture. Firstly, that it needs to be integrated. It needs to be highly integrated and deeply integrated into your existing infrastructure, right? You want to preserve the investment that you've already made in your organization in those technologies so that you can take advantage of those and use those technologies to their best advantage for the workloads that they're optimized for. Secondly, and very importantly, is taking advantage and leveraging the skills that you have already developed around your existing technologies. So Hadoop has obviously a new set of APIs, new set of interfaces, and that in and of itself are new things that your organization will need to learn. However, Hadoop and a Hadoop distribution that you'll want to use will be one that is deeply integrated within your existing infrastructure to your existing tools, lessening the burden on your organization and easing the ability for you to adopt this new technology and take advantage of it. So skills, highly, highly important. I think you'll hear Steve also talk some about the skills. And then finally, key services, right? The Hadoop platform must kind of offer key operational services that make it reliable and consistent within your organization so that you can run it in an operational enterprise mode and rely on it as a technology. So it has to be hardened, has to provide security, has to provide what I'll call the key utilities that are necessary to run that. So the Hadoop platform that you choose must provide those kind of key services. So just to summarize, it has to be integrated with your existing infrastructure, it has to enable you to take advantage of your existing skills, and it has to provide all of the key services of a modern data platform, operational services and utilities. And the good news is that's what the Hortonworks data platform does provide, and it provides it alongside of Teradata. And as we said, Teradata, Hadoop is a +1. It's additive to this overall infrastructure in terms of the modern data infrastructure. You can see some example tools that are integrated here, as well as Teradata. And again, you'll hear more about that integration with Teradata tools in just a second. But what we've done is deep integration with the Teradata tools and as well as other tools in order to make sure that it meets those requirements in terms of integration, in terms of enabling you to leverage your existing skills. For example, skills in tools like Teradata Viewpoint and skills in SQL. And as well, it provides all of those key services around the utilities, the manageability, interoperability, maintainability, all of those different things. So this really is a realization of what the modern data architecture would look like, particularly with with Teradata in that infrastructure. So what I'd like to do now is turn it over to Steve to take you through Hadoop, Teradata's role and data warehouse role on the modern data architecture.
Great, okay, thanks, John. Steve, I'm passing it over to you in just a moment here. You should have it.
Okay.
Do you see it there?
Yes.
Okay.
Just debating whether to show the whole desktop or not.
There you go.
Okay. All right, here we are. Does it look okay?
Yep, looks good.
All right, great. Hi, everyone. Thanks for having me. This is Steve Woolidge. You heard my intro. I work at Teradata in our labs division, so I work in our Silicon Valley office in San Carlos, California. And I've been involved with Hortonworks for a number of years and really in the Hadoop space for a while now, and putting together our product integration and our strategy around how we incorporate Hortonworks and Hadoop into this modern data architecture. We call it something a little bit differently. I think everybody has a different name for these types of things, but it's really about providing that best-of-breed, workload-specific infrastructure that supports the entire organization. Some of the research that I've read, I mean, there's tons of reports out there, but Gartner has talked about this for a while. They call it the logical data warehouse, where you've got master data management that really unifies and brings all this stuff together so that the enterprise can still get answers to their questions in a trusted way, and they see how data has been refined throughout the process. But it does give them that workload-specific platforms to support lots of different applications, users, and use cases. And the other graphic on the right talks about, on average, from the research that these guys did, EMA and Ninesight Consulting, on average, people have 3 to 5 different systems to go at big data. So Hadoop, the data warehouse, and discovery platforms are all part of that story in terms of supporting the enterprise. The way we talk about it within Teradata is this concept of a unified architecture. So everybody's got a version of this. But for us, from an analytics perspective and data management, there's really 3 key platforms as part of that. As you would expect, Teradata's history in the data warehouse makes that a natural key component of an enterprise. But the thing that's interesting is that as the warehouse has become more and more mission critical to organizations, it's become an operational system in a lot of ways. So a lot of companies are implementing a separate standalone area for data discovery at scale to look at these new data types, as John described, that are coming in, find some new value from that, and then model it into the warehouse and push that into the common metrics or the common business processes that you run your business on. And having a system like the data platform just to quickly load that information, to refine it, to process it, to do some initial exploration, but also make it available to the existing skill sets and tools that you've already got in your business intelligence world, let's say. That's also really important. And what we spend a lot of time on in our engineering group is how we stitch these things together so that data can move seamlessly between these platforms. The systems are easy to manage and monitor and administrate. I'll talk a little bit about how we do that. But really, it's about accessibility as well to the data. And we'll talk about how we integrate tightly with Hortonworks through its catalog to make that available to end users and applications. So this is just another view that talks about some of these patterns of usage, I'll say, on the different systems. And that's not to say that you always use all these systems, and there's not other systems, right? There's complex event processing and streaming and other types of systems, but this is just a guide to think about what is the sweet spot for a given technology to addressing some of these different use cases. And within Teradata, we build workload-specific platforms in the form factor of appliances. We also have software only available for a lot of these, but we're known for optimizing the hardware, bringing the software in a way that a customer can literally roll this into their data center, plug it in, have it up and running really, really quickly, and make it more manageable over time. So that's how we realize the unified or modern data architecture, however you want to say it. And specifically for Hadoop, one thing that we've done is we've partnered with Hortonworks to take their best-of-breed Hadoop distro and put it into this appliance form factor for our customers. But we don't just do that. We wrap around a lot of additional software to make it easier to administer and easier for end users to access the data. And I'll talk about some of these details, but just to call out one as an example, we have software that helps you deploy the cluster and do intelligent starting and stopping of nodes so that as you want to move in or do drive replacements, that kind of work is much easier than if you had done it on your own in your own cluster. And we'll still support customers that want to have their own deployment of Hadoop, and we still have the software integrations, but these are some of the things that we do to integrate onto hardware and make that performance and that experience really better for the customer. The other thing that we do is we partner with other best-of-breed vendors around things like security and things like metadata and ETL work. So we have software available with this appliance that gives you really good data lineage to transformation work that's happening in the cluster and make that more visible to the administrators. So just a taste of some of the things that we do. So we double-click into the modern data architecture. Really from a Hadoop perspective, you can think about how we integrate in with that system. So HDFS is a place where data is landed, it's loaded, you can do a lot of transformation work as well as end user access. And we've leveraged things like the ACE catalog project. So a lot of the structuring of the data is done within Hive, and then that structure is materialized through metadata services in ACE catalog. We take that through a software bridge we built called Teradata SQLH for the Teradata data warehouse, and then Aster SQLH for the discovery platform. And what that means is that people that want to query data can do it even if it sits in Hadoop as if it's just another, they view that data as if it's just another table in their model and can grab that data on the fly to do their analysis. We've also got the bulk data connectors like the Teradata connector for Hadoop that leverages Scoop and Hive framework to move data in bulk, but we also have more, I would say, lightweight or nimble methods to grab data as needed to complete queries. That allows you to store more data in Hadoop, but still be able to access it from some of these anti-SQL compliant tools that run on top of Teradata. That's more the end user side. The administration side, we also do a lot of value-added software. So Teradata Viewpoint is our monitoring and management software that integrates with all the Teradata products. We've extended that to work with Hortonworks HCPs. So we have all the services, alerts, system health, and analysis of how the cluster is performing, all materialized through that standard interface. And we leverage the open source Embari project and get the hooks and the APIs to be able to display that within the Teradata administrator's view. So it just makes it easier for them to monitor what's going on. And one value-added thing on top of that is unique to us. It's called the Teradata Vital Infrastructure. And essentially what that does is it wraps every workload-specific platform that we build, including the Teradata appliance for Hadoop, and it provides proactive monitoring, not only of the hardware and things like RAID controllers and network switches and cards, et cetera, but we monitor the operating system, the application software, and all the software that Teradata bundles into that workload-specific platform as well. And what we find is that we can identify 60 to 70% of incidents in a data center before a customer is even aware of that. So it allows us to provide them much more proactive support and better uptime overall for the system. So this is fully integrated with our Hadoop appliance with Hortonworks as well. So it's a big value add from an administration perspective of bringing Hadoop into your modern data architecture. A little bit more on the end user access. As I mentioned, Teradata and Aster SQL H leverage that H catalog metadata, and there's a couple benefits of that. One is it's secure access because you're leveraging the security and the optimizer on the Teradata system. So this becomes a point of entry, but I don't want to say control, but IT needs to understand who's accessing data. You've got auditing requirements. You've got to have lists of who's allowed to access what. This allows you to store data in Hadoop, but still add additional security on top of it. It's also 100% anti-SQL. There's a lot of discussion now about SQL on Hadoop, and there's a lot of projects to try and reach things like 100% anti-SQL compliance because we're leveraging the mature SQL optimizers and capabilities on the Teradata side. You get that for free if you are working through this interface. It runs fast because it goes straight against the data sets on the different nodes within Hadoop, and we move that data in parallel. So once you've defined a query, let's say you want to grab a date range of web clickstream, we tell HCatalog what data we're looking for. It tells us where it sits. We can go directly against those directories, let's say, for that given date range and pull back just that data that's needed to run that query. So it's fast, it's efficient, and it bypasses the Hive interface. So there's not that MapReduce processing in between. So it's really fast, efficient, and secure. And because everything within our unified data architecture, we run it on our InfiniBand backbone, which leverages a BiNet protocol, which is software that we've developed over 20 years. It really helps with network traffic for better performance as well as better reliability of that overall system that we put together. Now, the benefit of SQL H, I've talked a little bit about anti-SQL compliance. The other point of that is, as John mentioned, people have made a lot of investments in skills and tool sets, particularly business intelligence tools. So every BI tool that is certified against Teradata or Aster gets this certification for free. So now any tool that you've got, if you've got a Teradata system where it's certified, that all works against data in Hadoop and leverages just that software integration that we built with HCatalog. And we were the first ones to do that in the market last year in the June timeframe. So it's something that we've been doing for quite a while and seen a lot of interest from customers around. Some of the other logos on here, just to mention, Teradata doesn't do everything, and we do partner with best-of-breed software. So if you're looking at streaming technology or data transformation, things like metadata, we want to provide you the best choice for your architecture and help certify and bring these things together. The final benefit of SQL H is the analytic capabilities that you get in the discovery platform. So with Aster, we have spent a lot of time developing different out-of-the-box analytic functions that really help the business analysts become data scientists, if you will. It leverages languages like SQL, MapReduce, or frameworks, I should say. It gives you statistics, graph functions, specific operators to look at things like market basket analysis or collaborative filtering. as well as some transformation work to make the process of discovery accelerated and into hands of more people in your organization that are closer to the business. And this can all leverage data that's in Hadoop now because of that SQL-H integration that we built with HCatalog. So a common pattern that we've seen in terms of customer examples, and I'm going to give a couple now, is here. John talked about the new data types that were too big or too expensive to store in traditional architectures. Hadoop provides that great landing area and processing zone where you can bring in things like call center, voice records, IVR responses, email, images, etc., social feeds from Twitter, which is text essentially. Hadoop deals really well with that because of the file system and because of the flexible processing paradigms on top. Once you've, let's say, scored all the calls in your call center, say, show me the people that called in and had a good or a bad experience. I want to marry that up with other structured known data I have about individuals to better identify opportunities where we might be at risk of losing a customer. It gives you that additional insight by having that new data, and then push that into your operational systems to be able to take action on it. So every technology has a place and a role within this modern data architecture. A couple examples. I live in the Bay Area, so some folks that are definitely thought leaders and users of both data warehouse and Hadoop technology are eBay and LinkedIn. eBay is always changing. They've had a focus on analytics for a long, long time, and it's driving a lot of key initiatives at the company, like buyer experience on the website. How do we give them more relevant content? How do I improve search? How do I provide better buyer protection or mobile e-commerce? So they're constantly investing in new technologies and approaches to leverage different data types. And they actually have 3 distinct platforms for analytics. So they've got an enterprise data warehouse, which is set up. It's got a couple, I think last time I checked, it was 6+ petabytes of data in it. But it's really designed for transactional data, high user concurrency for a lot of the different end users, good accessibility through standard BI tools, and it supports hundreds of applications along with the end users. So it's a very optimized system for integrated data and reuse, security and all those things, but it does it with performance. And then the second system is called Singularity, where it's really set up for semi-structured data. It's a much larger system, closer to 40 petabytes of spinning disk, but it's really optimized for lower concurrency so that people can store more data, but also do some deeper things like behavioral analysis. One of the largest tables in that is 1 petabyte just on its own, which is close to 2 billion rows of information. And then Hadoop in their architecture is really for that unstructured complex data. And an even bigger cluster, the last I heard, it was over 40 petabytes of spinning disk, doing a lot of applications like text analytics, machine learning. It can also bring in data from those other analytics systems, such as the user behavior, et cetera. So that's one view of, eBay has presented a lot online in different places, so you can get a lot more detail on what they're doing. LinkedIn comes at it a little bit differently. They had a rich heritage in open source technology. I think they've actually built their own Hadoop distro or maintain it themselves. But they recently, within a couple of years, purchased a data warehouse from Teradata. So that's something that they've built for their business to get at the operational metrics and still have that Hadoop system for all the other applications, production things that they have out there, like people you may know. So again, it's best of breed. These systems need to work together. They share information. They share data. They often support a lot of the common end users, so they need to be tightly integrated, and that's part of what we're really focused on with Teradata Labs. There's a lot of things to consider when to use which technology, BDW or Hadoop. And I'm not going to go through this list, but there's just things that you can think about. A lot of it comes down to what's the data type, what are the schema requirements? Is it going to be relatively stable and not change much over time, or do I really want to be more open and flexible in terms of the schema that I need to define and not define as much up front, so more of an evolving schema? How important is anti-SQL compliance? If you've got the skill sets and a lot of programmers that are comfortable with Hadoop or have been trained up on those technologies, that may be fine for certain types of processing and analytics that you're doing. But if you've got a huge user community that you need to support and they have the BI tools in place, Things like SQLH and that bridge that we built can give them access to the data in Hadoop without them needing to learn new tools or put workload on that Hadoop system. So again, there's all checks and balances and things that need to be considered that we walk through with customers. And that's part of what we've developed on the Teradata side is outside of products, making sure that we can really provide guidance to customers on what's the right technology, what are the capabilities that are really required for a given business problem you're trying to solve. We come in with industry expertise and a rich heritage in data management. We've actually built out now a Hadoop team. So we've got skills on staff that can help implement Hadoop, get that first application up and running, figure out your data staging event, and then do knowledge transfer to the client site. More interesting, we also have optimization services. So now that you're bringing in a new technology, what are the right use cases? What are the applications that you can put on that? Is there some optimization of the overall infrastructure, and do you move some of that workload from one system to another to bring down the total cost of ownership? So that's something we have proactive conversations with customers about to make sure that they're constantly optimizing all the processes and technologies that they've got within the data architecture. So one last example use case, and I'll end on a demo before we open things up for projects or for questions, is a project that was happening with a retailer over in the Europe area. So this is a company that does a lot in store, but they also wanted to get smarter about their web presence with their clients. And in particular, they wanted to have the ability for their business analysts to do self-service insights to user behavior on the website to see if that impacts store assortment optimization or website design. And the way they thought about this was that if you think about an individual as they traverse a web page, they're going to leave a trail. And that trail is unique to them in many cases. It's almost like a DNA sequence, which is slightly different for each individual. So by using Hadoop and Hortonworks specifically together with Teradata, what they did was they set up a system where they could load that web clickstream much, much faster by taking advantage of the file system format of Hortonworks. And in this case, they're able to load a day's worth of log data in 60 seconds, so it's very fast. We can then sessionize that data, and what we mean by that is mapping out what are all the, if somebody comes to a browser, how do we define when that's a unique user versus maybe it's a public computer and somebody comes back and uses that same cookie ID, but it's a different session. So it's about anonymous browser behavior and then mapping out what are all the steps they took from the home page through search all the way to adding some to the basket and checking out. And then once that session is created in that view, we can then visualize it in a way that allows the business analyst to look for those patterns and identify cases where they can increase conversion rates, which by better microsegmentation, they can do that by 5 to 10%, as well as drive better web design and cross-sell. So let me pull up an example of what this would look like. So this is a visualization, and we provide some lightweight visualizations out of the box within the Aster Discovery platform just to showcase some of the things that we do on the analytics side. This can all be done in standard BI tools as well, but this gives you a view now of all that web clickstream. I can visually see how people have come in and traversed the website, whether I'm browsing for a product, then I go and do a search. And ultimately, the pattern we're identifying is we're looking for people that did it 3 steps, bought a product, and then we also want to look for 3 pages that they traversed afterwards. So once somebody buys something, what else are they looking for? Maybe they bought something and didn't realize that there was some other product that they want to have to go along with it. So what's cool about this is from a SQL perspective, this can just become prompted queries and reports that allow you to filter down and look at segments that are between, in this case, 1,600 or 10,000 users, be able to identify those unique individuals and then take some kind of an action on that segment. Another example of an analytic function is collaborative filtering. Things like market basket analysis. What products do people buy together? This can feed into recommendation engines, but this is a tool that a product manager could use to say, okay, if I'm selling sporting goods and I want to understand people that bought this women's 3-season jacket, what other products did they buy along with it? Are there strong relationships between some of these products or not. And this might help create the list of products that I want to co-market together around a given product that's selling really well, one of those leaders for us. So, again, good visualization helps speed that time to insight. And this can be leveraging, again, SQL access back to Hadoop data where you're storing that web click stream or product transaction data, and then doing additional extended visualization on top of that. So that's how we integrate Hadoop in with the Teradata environment to really bring more value to our customers. So with that, I will turn things back over to Tim to open up Q&A.
Thank you, Steve. Thank you, John. Those were both really very informative, detailed, and I love the live demo there, Steve, so nice work. Give me just a moment here. So we're at the Q&A session of the portion of the webinar today. Thank you to the audience for providing some great questions. A lot of questions have come in, so we'll try to get to as many as we can. But while we do the Q&A session, I want to make sure that everyone sees the current slide. There's some information in terms of a few links. The first one is for the Teradata and Hortonworks partnership. You can get more information on that link there, as well as the two following links are specific to the products for Aster Express and the Sandbox. And both John and Steve have provided their emails. So following today's webinar, if you would like to contact them for additional questions, you can do so. So this will be up during the entire time, so you'll have time to take down the information. But we do have some questions come in, so I'm going to start. So John, this is a question for you. Can you provide a little bit more detail on the six types of data types that you discussed earlier in your presentation?
Sure. Thanks, Tim, and thanks, Steve. Thanks, everybody. I think it's very interesting in terms of the data types. If we're going to provide more detail, I'd say one thing we want to give you more details on is where are some of those data types being used? What are some of the specific use cases for those? And let me just sort of run through just a couple. It's certainly something we can always follow up on a later time. But for example, we see things like sensor data. We talked a lot about sensors and machine collected data. We see that being used for a lot of different industries. For example, in retail, we see sensor data being used to optimize store layouts, right? To figure out what is the traffic pattern of people as they move through, whether it's being collected off of cell phones or some other sensor that is available within the store. It could be video, in order to make sure that people are able to move through the store optimally. It's also used in manufacturing, for example, in supply chain and logistics. How do materials both move through factory floor, but also how do they move out to outlets and other places that need to distribute those. And also in manufacturing, we see them on assembly line and quality assurance, right? What are the failure rates of parts, and what might be some of the causes of those? That's just a few of server data. For example, we see geospatial data being used in a bunch of different ways. For example, in telecom, with call data records and analyzing cell phone traffic and patterns to understand where telecommunication companies might put more cell phone towers. Use it for new product development by looking at traffic patterns and patterns of use for applications and cell phones and smartphones and the like for new product development and telecommunications. Server logs, one of the largest use cases for Hadoop in this modern data architecture, used in industries like financial services for applications around fraud prevention and trade risk analysis and maximizing various kinds of deposit patterns. So there's a lot of different ways these data types, these six types of data are being used out in industry to improve businesses.
Very good. Okay. Steve, the next question is for you. There's been a few questions coming in about the Teradata SQL H. So I'm going to combine these two. One, if you can go into a little bit more detail about it. And then the second part of the question seems to be, when would you use Teradata or Aster SQL H instead of Hive?
Sure. So I'm trying to think of more detail to give without jumping into the basement. But essentially, SQL H is an extension of the SQL optimizers on both Teradata and Aster to to be able to view the data that's in hcatalog. So hcatalog is an abstraction of the files that are in Hadoop, and it's really metadata about where those file types are stored. So it essentially becomes another field that you can access in a query. And we do have some ability to push down filtering, so we can just specify the type of data we want to, or the amount of data we want to bring back. It doesn't have to bring over the entire directory. It could just take whatever structure's been created there in Hive and expose via the metadata catalog. You just bring back what's required. So there's more details I could get somebody offline in terms of how the architecture works, how we communicate. Once we've understood where that data is, there's a contract between the SQL optimizer, which basically knows how to move the data from the individual amps in the case of Teradata, or the individual workers in the case of Aster, and pipeline that data in MPP fashion directly from the data splits that are on the different Hadoop nodes. So it's high performance. It gives you anti-SQL compliance, which is kind of answering the question of when we use it over Hive. Hive has built out more and more SQL compliance over time, but Teradata has had a SQL optimizer for 20, 30 years, so it's just much more mature in terms of some of the expressions that can be handled and leveraged by that machine-generated BI tool, right? I'd say the other thing is that it really comes to what's your data placement strategy. So if you're going to have data that's in Hadoop, but a lot of your analysis is done on another system like the Aster Discovery Platform or the data warehouse, SQLH provides that kind of best-of-breed approach, in that you can have data that's in Hadoop, leverage it for storage and cost, still be able to access it through that SQL interface and join it with other data that you're analyzing on a day-to-day basis in your other system. For people that are going to keep all of their data, let's say, in Hadoop and don't even have a data warehouse, Hive provides a good interface for queries. But it really depends on the architecture that somebody has set up. So those are just a couple points, and there's certainly more on when to use SQLH versus Hive.
Okay, very good. Thanks for that detailed answer. This is a question that I think could be for both of you, but John, why don't you start? I'll pass it to you first. The question is, when talking about integrating existing traditional data sets into Hadoop, what role do you see for a staggering layer in data warehouse, and does this approach make the layer now somewhat redundant?
Yeah, good question. So one of the use cases we see with Hadoop and kind of traditional data sources is to take data that was typically being pushed into an archive, so on some kind of offline version, right? So you have some kind of sliding window of, X or N months, 6 or 12 or 13 months, that's typically kept within the data warehouse, possibly longer. Steve can talk to specifics, but we see data that had been rolled off of that system and put onto tape being brought back online and using Hadoop as a near-line system, right? So that using things like SQLH and the query capability that Teradata provides enables queries across a very broad number of years of data and broader level of analytics into more depth than was available before. So there's still all of the tiering of hot and cold data that exists within Teradata that's very, very powerful, but that data that was being taken offline is one that would be left and brought back online into Hadoop. I don't know, Steve, you want to add on to that?
Okay.
I think those are good examples. I think that, we'll probably get some more details on some of those trade-offs as well.
Okay. All right, Steve, the next question I'm going to pass to you is, how do I decide which workloads make the most sense for Hadoop and for the data warehouse?
Yeah, always a question we get. So I had put up a slide earlier that talked about some of the considerations, things like security, SQL compliance, the types of skill sets really that you have in-house. And there's no silver bullet. I think any good architect has to work with the IT and business stakeholders to talk about what are the requirements. And when it comes down to things like ETL, that's a common question of, other ETL jobs that I can move on to Hadoop, because it does have so much processing power and so much scale. And yeah, that makes sense conceptually, but you have to look at things like, well, how many jobs have I written? Is it all done in a tool like Informatica, or is it all custom scripting that I've done? So what's it going to cost me to translate that from one system to another and rebuild that translation layer? So there's a lot of costs that need to be looked at. There's also things like reference data. So if you've already got a bunch of your data that's being transformed on the warehouse along with other tables for reference lookups that you need to make to do that transformation work, it might be really hard to offload that onto something else. So those are some of the things that our teams get involved with in conversations. We've got a lot more details in terms of worksheets. I would say that there's also, for people that are looking at this in detail, there's a new white paper that was published by Richard Winter that talks about the total cost of data. And he really looks in detail at, what are the types of applications that can run really well on Hadoop? What are the ones that run really well on a data warehouse? And what's it cost to have them on those various systems? So it comes down to the numbers of users, the types of analytics, the numbers of queries. It's not a clean-cut answer, is the short answer, but there's a lot of research that's been done in this area out there, and Richard Winter's papers are a really good example of that that's really practical and usable.
Okay. Well, thanks for a very thoughtful answer to the question. A common question in these settings is, and I think very appropriate, is, what are the first steps to moving towards a modern data architecture? How does someone get started using what you proposed? And this is a question for both of you, frankly.
Yeah, okay. Steve, I'll go first, and then you can jump in. I guess from our perspective and from a Hadoop perspective, our suggestion is to not try to boil the ocean, but pick a single data set or two that you want to store and start to analyze, and pick a simple business problem that you want to try to solve with that, so a new kind of analysis. So start small with a particular data set in mind that you want to start to capture, and then think about the ways that you want to integrate that into or use some of the existing data that you're already capturing as part of that process. So don't start too big, don't try to boil the ocean, but do start with a Hadoop deployment like Hortonworks Data Platform or distribution that meets those kind of standard requirements that we talked about earlier in the webinar.
Okay. Steve, any thoughts from you?
Yeah, I agree in that you want to start with that first business application. There's got to be ROI at the end of the tunnel. I do see a lot of customers that are just trying to figure out. There's so much excitement around this area now. I've been in the industry for a while, and it's never been as people are looking for silver bullets and easy solutions, and they get excited about the technology. But if you don't have that business case, it's hard to really justify bringing anything in. But we do have a lot of companies that just want to start and get systems set up and integrated so they can start to play around as well. So, but having that sponsorship and that value you can provide back to the business is always the key thing. And there's a lot of great examples of use cases on both of our sites. And if there's any questions you've got on areas for your business, feel free to reach out to one of us.
Okay, very good. There were a few questions about sort of unstructured data and queries and whatnot. So, John, I'm going to ask this question of you. It's how would you use the platform to support unstructured queries? And if you want to move beyond the question and go into some of the unstructured data questions.
Sure. I mean, there's lots of tools that are built into the platform for manipulating and analyzing data. And I don't know whether you mean unstructured queries or query against unstructured data. First thing that you're typically going to do is use some of the tools that are inherent in Hadoop to provide some structure on some of the unstructured data. So, for example, whether it's Pig or Hive, one of those two tools you can use to manipulate the data, and I'll call it chewing it up, right? So removing duplicates and other kind of standard low-level transformational activities that are common when you're collecting, say, server data or weblog data that might have lots of duplicates or inconsistencies. So first thing is do some of that low-level processing, and again, it's typically done with a scripting language like Pig within the system. But then if you want to do queries against that, then you can do queries using Hive, which has a standard query language called Hive2L. It's very SQL-like, I'll call it. and it has constructs that allow you to query against that data in a broad set of ways. And then if you want to go deeper or have more interactive queries, then you can use something like SQL-H or query it from either Teradata or the Astra product to have a more interactive or iterative interaction with the data.
Okay, very good. I think we have time for maybe one last question. So, Steve, I'm going to pass this one to you. Will Teradata support non-appliance Hortonworks clusters in the unified data architecture?
Yeah, great question. I didn't talk about it on this call too much, but in addition to our appliance model, we also support software only. So we will support customers that have their own Hadoop cluster, and for Hortonworks, we will actually support it as well. So it's integrated in with our support infrastructure, and we'll support that as if it's just a Teradata product, which includes all the connectors and adapters that we've integrated between HDP and the rest of our unified data architecture. So yes, we recognize that companies are investing in being able to have that engineering ops or engineering IT group, DevOps, that can build their own clusters. And once you get to a certain scale with Hadoop, it makes sense to build it in that way. So we support that as well, yes.
Okay, excellent.